We are Yu Shendong, Andrew Burks, and Alexander Politovich, and this project was completed at University of Illinois at Chicago as part of the Visual Data Science graduate course in fall 2020. We designed this project in collaboration with Dr. Belvich and Dr. Ascoli from the University of Illinois at Chicago Hospital. We followed an activity-centered design process with particular emphasis on the functionality of the system and with repeated feedback from our client, course staff, and classmates. The microscopy data used in this project image alveoli, neutrophils, and interstitial space in the lungs of mice. From the combination of these image sets, we segment alveoli and neutrophil features across each experiment. The segmented features and much more are seen in our web-based visualization. The caveat diagrams on the left-hand side of the interface each represent one experiment and allow a user to visually compare entire experiments or to inspect a single summary attribute to compare the computed values. A pair of juxtaposed, mirrored timelines allow you to seek the different points in each experiment and allow for global navigation. Now, we will look in more detail at the bottom experiment. The rightmost portion of the experiment pane holds the processed image data with overlaid alveoli contours and neutrophil locations and allows a user to filter out certain channels of data. Working towards the left, the next chart overlays all respiratory cycles to show the change in airspace over time. It also allows a user to click on a single cycle of interest to jump to that point in the experiment. For local navigation, a user may click and drag the time point to seek within a single cycle with precision. The leftmost area and line charts in the experiment pane show the average alveolar area percentage and number of neutrophils at the selected stage across all respiratory cycles. Some insights may be found through visual inspection when comparing between the juxtaposed experiments. For example, the more injured lung on the top clearly has a significantly steeper exhalation curve than the treatment lung on the bottom, which is consistent with what is to be expected from a more injured lung. In another method of comparison, one may use the time controls near the color legend to view the image sets as a video and step forward, backward, speed up, or slow down the playback while watching the experiments and other linked visualizations update in tandem. For explicit comparisons of higher-level information, the right-hand side of the visualization contains 3 charts. At the top, a slope chart allows a user to compare the changes in each experiment from start to end. In the middle, violin charts plot the area distribution for all 3 feature types, and a checkbox will filter the data to only show the distribution at points of max inflation. Last, the difference chart at the bottom shows the absolute difference in feature area between the 2 experiments across all respiratory cycles. Our visualization application scaffolds layers of data processing and linked visualization upon the foundation of microscopy lung imaging data to support visual analysis and comparison at multiple levels and timescales.